As human beings, we're very accustomed to talking in a decimal system. Decimal is a numbering system that works on units of 10. So what happens is we would go from 0 through 9, and then once we go to 9, we add another set of digits in there. So our 10th item kicks us up to another set of digits. Now, if we multiply that by 10, such as 10 times 10, it would kick us up where we have another number for 100. If we multiply that by 10 again, we'd add another number. 10, another number, and so on and so on. So decimal thinks in tens. Binary thinks in twos. It's going to be either a 0 or a 1, and it counts like that. So you'd start out 0 would be nothing more than 0 in binary. 1 would be represented by 1. If we looked at 2 in decimal versus binary, we would have the next level come in the binary. So 2 would be a 1 then a 0. We would fill in that 0 when we went to 3. We'd have nothing left here, so we'd have to add the next level in binary. So 4 would be 1, 0, 0. 5 would be 1, 0. We add a 1 here. 6, we'd go up to the next level. So we'd have 1, 1, 0. 7, we'd fill that in. 1, 1, 1. 8, we'd go up to the next level. 1, and this becomes zeros. 9, we'd have our 1 with our zeros. We'd add a 1 here. 10, we'd go up to the next level. 10, 10. 11, we fill this in. 1, 0, 1, 1. 12, 13, 14, 15. You can see this is all full, so the only thing we could do is add to the next level. That's 16. And we work on filling those in as we move up. So if we had to do some conversions between binary and decimal to understand what the computer is going through in order to keep these IP addresses straight, let's look at a binary value chart. Now what I did here is I have the first 8 binary digits. Remember, the system we're using for IP addresses breaks everything up into octets. So you only have to think of 8 bits at a time. So that's why this chart is very handy. If we looked at 8 bits, such as these numbers represented by 1s here, the first bit has a value of 1. That would kick us back to here. Second bit has a value of 2. We go our second bit, a value of 2. Third bit would have a value of 4. So the number 4 would be 1, 0, 0. Let's go back here and see if our chart's right. Okay, that value, 4, is 1, 0, 0. The fourth bit up is worth 8. Let's go up here. Okay, here's our 8. Next bit up is worth 16. Let's look up here, 16. Next bit is worth 32. Next bit is worth 64. Next is 128. So if you need to convert binary to decimal or decimal back to binary, you can very easily do so by memorizing these numbers in this chart. Let's go on and take a look. If we had a binary number and we wish to convert it to a decimal, let's say we have a binary number here, and it's 11000101. We would take this number, and we would say, let's line it up over our values. And these values are the values that I pulled from the chart right above, right here. I take my 1, and I say, okay, I have 128. Let's bring that down. I have a 1 right here. That's worth 64. Let's bring that down. I don't have anything here. So for 32, I could bring down to 0. I don't have anything here. For 16, I bring down 0. Nothing here. For 8, I bring down to 0. I have a 1 here. The value for this is worth 4. So I bring down to 4. 0. There's nothing here. So I bring down to 0. And then 1, I bring down to 1. I have these numbers here. If I added these numbers up, 128 plus 64 plus 4 plus 1, it's going to give me the value of 197. If we needed to convert the other way around, decimal to binary, We take our decimal number, we line up our chart like I have here, we say, okay, this number is 210. What is the highest value from this that I can subtract from it? Since 210, the highest value I can subtract is 128. So I take 210, and I subtract 128, and I have 82 left over. I leave this marked here, but I've got 128 that I used so far. I take my 82 in this segment here, and I look at my binary chart. I say, what is the highest number that I can subtract from it? I go up, I go up, I go up. 64 I can subtract, but I cannot subtract 128. So I subtract 64. Okay, so I have an item here as well. I remember that I had that item here, just like I had the item here from the previous. And I take 82 minus 64, and this equals 18. I go a little further with my subtraction. I take 18, I work my way up, I subtract the highest number that I can subtract from it. I obviously can't subtract 32 from 18 without getting a negative number, but I can subtract 16. So I have a value here. 18 minus 16 is a remainder of 2. I go down a little further. Here's my chart again. I take 2, and I work my way up. I can't subtract any of these from 2 without getting a negative number, but I can subtract 2. So 2 minus 2 equals 0. Now, I bring my numbers down. So I brought the 128 down from up here. I bring the 64 down to here. 32, I didn't subtract by 32 at all, so I don't bring anything down there. I bring the 16 down because I subtract with 16 right here. I didn't do anything with 8 or 4, but I subtracted 2, and I didn't subtract anything in the 1 column. So I have my numbers up here that add up to 210, but I look at my binary, and this is my binary number I just converted. I have 1, 1, 0, 1, 0, 0, 1, 0. And I got that from converting, going through this process. What I'd like you to do is to get a little bit of practice. So when this particular movie concludes, I'd like you to go to the Stuff folder on your CD and find a document that you can open up with your web browser so you can print it out. That's going to be 02 space binary. So it's going to be called O2 binary. And in there, it's going to have something that looks very much like this. You'll have a little more room to write in. And I'm going to ask you to convert these binary numbers over to decimal. And then I'm going to ask you to go through some decimal to binary conversions as well. Once you've completed that, what I'm going to ask you to do is go ahead and open up the next segment. And in the next segment, I'll present the solution to these conversions so you can see if you did everything properly.